clearly one of the more popular uses of RenderMap is its ability to cook in complex lighting effect into an object's texture. So this obviously works best in situations where you have static lighting conditions over the course of the animation. So a lot of times you'll have an object that it might be UV unfolded, but in the process of making an efficient UV map, you can have overlapping UVs like that. And so the render mapping of it is a bit of a time-consuming process because you need to create unique, non-overlapping UVs to the entire object. And doing that manually can be quite time-consuming. But what you can do is use the unique UV feature along with render map to basically automate the whole process. So a typical example would be a complex object. For example, we have this kind of city block scene, and say we want to cook in final gathering lighting into the texture. So normally this would be a fairly complex object to actually unfold and unwrap, and would take quite a bit of time. But we're going to take a look at using some automated tools. So the first thing we want to do actually is, I guess we'll light it for final gathering. So I'm just going to get a simple grid here. Let's just scale it up a little bit, something like that. And because we're using final gathering, I'm just going to put a constant material on it, which allows me to throw a lot of light off this object, makes it very emissive for final gathering rays. So we'll do something like that. Let's just take a look how that looks. So what I'm going to do is just create another one on the other side, just to cast a different kind of light color in. And this one here, let's just make it a blue color. There we go. We could just scale that up. Okay, so once we have something that we like, I'm not going to fuss too much about it. The next step is applying the unique UV properties. So let's just switch to another XSI here and take a look at it. What I've done is applied it to the sphere. And basically, if we open up the unique UV operator, we can see that what it does basically, there's a few different methods for creating the UVs. Individual polypacking. This is similar to what we had in 3.5. So basically takes every polygon, lays it out sequentially from largest size to smallest size, and basically we can control the spacing and the resolution of the actual texture coverage it uses. So this is a pretty efficient way. The shortcoming is render mapping and other XSI tools can understand this UV information, but say if you brought this into a paint program and you want to add some detail in certain buildings or certain specific polygons, it's very hard to know exactly where those polygons sit, and it's not really the kind of UV set you can easily edit outside of the 3D software. So we have some new options now. Angle grouping. What this does is basically use a heuristic to determine how to break apart the polygons. So essentially what happens is a vector is created for the object, and then all polygons that are oriented within a certain degree threshold of that vector will be grouped together as an island. So right now, well, let's just set the angle here, tolerance to 45 degrees. So all the polygons within 45 degrees of that vector will be grouped together. And so you can see we get this kind of fairly visually coherent UV sampling. You can see as I decrease the tolerance, so we've got a very more minute threshold for the angle. All the polygons kind of start breaking apart and create their own separate type of islands. So if I eventually went with a threshold tolerance of 1, so the polygons within 1 degree would be grouped together, you can see we're pretty much back to our unique UV kind of layout. And as we increase it there, you can see we get larger islands. And there's also a sort of symmetry heuristic with the angle grouping. So if it finds a group of similarly sized and oriented polygons on two sides of an object, it'll sort of understand that there's a symmetry within the model and separate it that way. So there's a few neat things in there to play with. And you can see, obviously, this is a lot easier to bring into a paint program and edit the UVs. We've also got some pre-smoothing. Basically what this is the deform smooth operator, but incorporated into the polypacking tool. And basically what this allows you to do is like areas like the ear or the eyes where you have some kind of like folding of the polygons over one another. The smoothing will let you flatten out the actual UV so they kind of open up and you don't have as much overlap. So you can try playing with that a little bit. On the sphere example, it doesn't really show up, but it is actually quite effective. We have some controls for setting the origin, the U and V kind of bounding box area. We can set the resolution here as well as the spacing between the different islands, so we can get them closer together or spread them apart this way. So that's kind of an overview of the polypacking tool. Let's switch back to our production example. So what we want to do is apply the unique UV property to our city. So we can just go get property, texture projection, unique UVs. And what I'm going to do is use the individual polypacking option. Because the city is quite large, you want to specify, obviously, a large enough resolution for the UVs to be spread across, because you've got to go up and down the different surface faces of the building. So if you actually want to do close-ups on the city, you're probably better off going even larger, maybe 4K by 4K. And keep the UV pixel amount here fairly small to maximize the texture usage. So once we have that, let's just take a look at Texture Editor and see what we get. We'll switch to that projection. So there we go. Let's just expand the Texture Editor so you can see all the UVs have been laid out. What's really smart to do is to actually freeze the polypack operator, because anytime we make changes to the mesh, the operator stack is reevaluated, and this can actually take quite a bit of time to generate. So it's a good idea to just select that and freeze it. Okay, there we go. Now the only thing we need to do is apply a render map property. And we'll just name this to something unique, render map city. Specify the resolution, 2048 as well. It's a good idea to use the same amount, the same size as you specified in the polypack. So this tends to give a little more accurate results. So we want to use the explicit UVs we created. Something you have to remember is the render map uses the actual render options. So you want to make sure you have your final gathering enabled as well as your samplings properly set for the actual render options. So let's just copy the options from the region. And what we want to do is just auto-compute this, and let's set this to something like 100. So minimize the artifacting, aliasing. Everything else there looks okay. So that's it. All we have to do is actually generate the map now. Okay, so once the map's generated, we can just connect it to our actual mesh. Render map city. There we go. So you can see the actual color information is set up in there. What we want to do is go over to the texture decal mode. That seems a bit peculiar. Doesn't seem to be taking the proper. Might just be an OGL refresh problem. There we go. Okay, the one thing to remember too is that you want to go on the actual image clip, and under texturing tab, you want to set the actual maximum OGL resolution properly. So you can see here the result looks pretty good, but we have some kind of artifact in here, so we want to set that to the actual resolution we specified in the render map. And there you go, it's all cleaned up. So there we go, we've got the final gathering baked into the texture using the unique UV feature.